Extra example number 2 from section 11.1, landline surveys. According to the 2000 census of all U.S. residents aged 20 and older, 19.1% are in their 20s, 21.5% are in their 30s, 21.1% are in their 40s, 15.5% are in their 50s, and 22.8% are 60 and older. The table below shows the age distribution for a sample of U.S. residents aged 20 and older. But note, there's only one population here. That's just U.S. residents. And we're taking a sample from one population. It's a categorical variable because you're fitting into one of these categories. It's not quantitative. It's categorical. And we're looking at the distribution of the categorical variable in terms of your age category. So the table shows the age distribution for a sample of age 20 and older. Members of the sample were chosen by randomly dialing landline telephone numbers. Do these data provide convincing evidence that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents? Okay, so in the way this question is asked is how you'll see it on the AP test. It will not say do a state plan, do conclude. You have to know that that's what you have to do. So you automatically go to state plan, do conclude. So for number 2, landline surveys, state. This is how we would state that. We would say the age distribution of people, the age distribution of people who answer landline telephone surveys is the same as the age distribution of all U.S. residents, as age distribution of all U.S. residents. So that's H naught. H naught. Remember, H naught is still the statement of no change or statement of equality. And then H sub A, alternative hypothesis, is I'm just going to write it's everything above but is not the same. And that's all. Is not the same. So H naught, it is the same. H sub A, it is not the same. That's state. Then our plan is to be sure you name the test. Maybe do that first. Perform chi-square goodness of fit. Feel free to abbreviate goodness of fit test if the conditions are met. So 1, random, and it is taken, the data's from a random sample. 2 is where we compute our expected counts and make sure they're all at least 5. So yeah, on the AP test, you cannot just say the expected counts are greater than 5. You have to actually compute them to test that condition. Are greater than or equal to 5. So we would do, there's a total of 10, what we're expecting is a total, if we take a sample of 1048, which the question says, or in the table it shows, in this table, here's our sample, right? And there's 1048 total. So we would expect, if the distribution is the same, we would expect the percentage to also be the same in our sample. So it's 1048 times 0.215 for 21.5%. 0.215. Sorry, that's not the first one. The first one is 1048 times 0.191 for 19.1%. So that gives us 200.2, so that's good. That's certainly greater than 5. Then we would do 1048 times 0.215 for 21.5% is 225.3, and 1048 times for 21.1%, 0.211, 221.1, 1048.155 for 15.5%, 162.4, and 1048 times for 22.8% are 60 and older, 0.228, we would expect 238.9. Okay, so you actually have to show it. And then 3 is the 10% condition. It's reasonable to assume there's at least 10 times 1048. So I'll just put independent and I'll put a check because we've done this so many times. But I'll say verbally, you would say it's reasonable to assume there are at least 10 times 1048 U.S. residents. So that's our plan. And then our do is we're going to compute chi-squared. Now you can shortcut this on the test and on my test and the AP test by just showing the first two. So you can do chi-squared equals, you would literally write it like this: 141 minus 200.2 squared over 200.2. You're just going to show the first two, minus 225.3 squared over 225.3, and then you're going to say plus dot dot dot, no matter how many there are, no matter how many categories there are, dot dot dot, and then you'll do the rest on your calculator, and you get a large chi-squared test statistic of 48.2. You can't draw any conclusions yet until you calculate the p-value. So what the degrees of freedom are? How many categories are there? 5, yep. So 5 minus 1 is 4. And you do p-value is, on your calculator, you do chi-squared CDF of 48.2 to infinity. It's always going to be to the right on this, which is nice, because you're always going to get a positive value for chi-squared, because you're squaring and you're taking the sum of squares, so it's always positive. You don't have to worry about it being negative. and then 4, so you would do that on your calculator. You would get close to 0, so just you can say approximately 0, and then you would conclude that conclusion needs 2 parts, because p-value is less than 0.05, which is, if we're not given a significance level, we assume it's 5%. We reject H0, and then explain in context. So we do have convincing evidence. We have convincing evidence that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents. Convincing evidence that the age distribution of people who answer, which is not surprising with a chi-squared of 48.2, distribution of people who answer landline telephone surveys is not the same as age distribution of all U.S. residents. Okay.